Okay, welcome back to Physical Science Online for Electricity Notes video number 2. I'm going to try to get done during this video. I think I got it. We'll see. So circuit diagrams, we did a little bit of circuit diagrams. In general, we just want you to know the basics. The very basics is that we use some symbols to represent certain things, 4 of which you are expected to know. So you're expected to know a cell or a power source, a lamp or a resistor with that circle at the X, a switch just means that it opens and closes the circuit. That's what your light switch in your house does. That's why it's called a switch, opens and closes the circuit. And then wires to connect everything. Those are the 4 that you're expected to know and be familiar with. Then the other thing, our last focus is on parallel versus series circuits. Really simple. Keeping it really simple. We're not doing anything too complex, other than maybe your assignment with the house is the most complex you will get. So in a series, there's only one path for the electricity to take. So if one of those lights goes out, the whole thing goes out. In parallel, though, there's those multiple paths that it can go down, and if one light goes out, the other 2 are going to stay on. This leads us to a couple things you need to know. So in a series circuit, already talked about that one. Last thing is what happens to the voltage and the resistance. Basically, I'm trying to see how this one's worded. Voltage, we don't need to know the voltage one as well. Sorry, if you want to change in your notes, so I don't need to remake this video, change it to resistance increases. Resistance increases as you add more in series. Just like when you added more straws and it got harder and harder to suck it through because there was more resistance, more rocks. Nope, and it's at the bottom there that you can just barely see that. So I did have the right thing, just had an extra little, the voltage relationship isn't needed this year. Okay, parallel, instead, parallel, the current through each bulb or each resistor remains the same. So if the current remains the same and the voltage remains the same, then the resistance has to drop. The overall resistance has to drop. It's really weird to think about. It's the weirdest thing in electricity, that as you add more light bulbs, the overall resistance of the circuit actually goes down. Even though each one has the same resistance, the overall resistance goes down. It's basically because you're given the electrons choices and they choose the path of least resistance. That means that the current increases as you add more bulbs and the brightness stays the same. So when we did our series lab with light bulbs, you maybe noticed a little bit of difference in brightness. That was because our power source wasn't enough to keep up with the increase in current. More so than for any other relationship. So we are limited by some things, but brightness should stay the same. You can pull pieces out and current of the whole thing increases, of all of them in series or parallel does increase. I think that's it. Yeah, that's it for this year. So I did get done 2 videos. Congrats to me. A little pat on the back of my back. There you go. Enjoy.